It's 1942, and the Germans have just released a new Enigma machine. It can produce 150 billion different combinations every second. You might call it the most complex Rubik's Cube ever made. For most, it seems practically unbreakable, which is why they called it Verdian's Cube or even the Devil's Cube. But you are not most people. You are a top secret team of British codebreakers tasked with cracking Enigma. The fate of the world literally rests on your shoulders. How do you do it? This is a true story about a man who did the impossible, who built a machine that changed the course of human history, and no one knew about it for decades. They erased his name from history books, but we will never forget him. His name was Alan Turing. This is how he and his team cracked the unbreakable Enigma code. But first, let me give you some context. It's 1939 and Germany has just declared war on Poland. Winston Churchill calls for action. Britain and France have a duty to defend Poland. The British Expeditionary Force marches to war. There's just one problem. They don't know what Germany's plans are. Not yet anyway. The German military uses something called the Enigma code. It's basically a way of encrypting messages so only the intended recipient can understand them. But this isn't your typical Caesar cipher where you shift each letter 3 spaces down the alphabet. No, this is next level stuff. The Enigma machine looks like a typewriter, but it works like a really complex combination lock. Every letter has a series of plugs that need to be configured just right. And then there's the rotors. Each rotor has 26 letters, but when you press a key, it types out a different letter. And it's not a one-to-one correspondence. A could print B, E could print F, and so on. Plus, the rotors change positions after every message. So if you want to send the letter A, you actually have to type H and so on. And to make things even harder, the machine changes the settings once every 3 days. To crack the Enigma code, you need to figure all of this out and do it fast. The lives of countless people depend on it. At Bletchley Park in rural England, a team of codebreakers led by the brilliant mathematician Alan Turing rises to the challenge. First, they had to find a way to get hold of an Enigma machine. And after several failed attempts, one of Turing's team members, a Polish refugee named Marian Rejewski, remembered that Poland had already cracked the Enigma code before the Germans invaded. He and his team had taken some Enigma machines with them when they fled. The British were very grateful for this tip. They traveled to Poland, met up with Rejewski's contacts, and got their hands on an Enigma machine. Now the real work could begin. Turing and his team analyzed everything they could get their hands on. They studied the Enigma machine, its inner workings, its strengths, its weaknesses. They wanted to understand it inside and out, but time was ticking. They couldn't afford to waste time experimenting. They needed a systematic approach, a way to test every possible combination quickly and efficiently. And that's when Turing had a breakthrough. He designed a machine that could do the hard work for them, a machine that would test thousands of possibilities in seconds. He called it the bomb. To build the bomb, Turing and his team assembled a group of engineers and technicians. Together, they worked day and night to bring Turing's vision to life. They scavenged parts from old typewriters, telephone exchanges, even wartime bomb equipment. They wired them together, creating a tangle of cables and circuits that would become the first programmable computer. The bomb was a marvel of engineering. It consisted of 3 main parts. First, there was the keyboard, which allowed operators to input the intercepted German messages. Then there were the rotors, which were designed to mimic those of the Enigma machine. And finally, there was the printer, which would output the decoded messages. The bomb was a game changer. What once seemed impossible now seemed possible. The team could try thousands of settings in minutes instead of weeks. But even with the bomb, cracking the Enigma code was a daunting task. They needed to start with a hunch, a guess, or perhaps an insight gained from other intercepted messages. Once they had a hunch, they could feed it into the machine and see if it was correct. If not, they would adjust their hunch and try again and again and again. It was a painstaking process. But slowly, very slowly, they began to make progress. By 1941, the team was able to decode some German naval messages. They learned about German plans and movements and shared this intelligence with the Navy. As a result, the Germans lost many valuable U-boats during this time. Even though the Germans kept changing the Enigma's settings, Turing and his team were always one step ahead. Thanks to their efforts, the Allies won many important battles. They saved countless lives. In fact, historians estimate that the work done at Bletchley Park shortened the war by 2 years. That's a staggering statistic, 2 years. It means that millions of people didn't die because of the work done by Turing and his team. But even as the Allies celebrated their victories, Turing and his team were working in secrecy. Their work was classified, top secret, and they couldn't talk about it to anyone, not even their families. It was a lonely existence, but they knew it had to be. If the Germans discovered that the Enigma code had been broken, it would be catastrophic, and Turing and his team worked in silence. By 1945, the war in Europe was over. Victory was in sight, but the work at Bletchley Park was far from finished. The Allies needed to know what the Germans were up to in the final days of the war. They needed to know about the Holocaust, Hitler's plan to exterminate all Jews in Europe. Thanks to the work of Turing and his team, they didn't know about it. The British government decided to keep this knowledge secret. They didn't want to upset the fragile peace with tales of wartime atrocities. Instead, they created a myth. They said that the killings were carried out by ordinary German soldiers, not by the Nazi leadership. This myth stuck around for decades, even after the full story came out. After the war, Turing returned to mathematics. He helped design some of the earliest computers and taught at Cambridge University, but his career was cut short when he was convicted of gross indecency. For having a relationship with a man, the British government took away his security clearance and forced him to undergo chemical castration. In 1954, at the age of 51, he died by suicide. Today, Turing is finally getting the recognition he deserves. Statues have been erected in his honor, streets named, films made. But perhaps the best tribute to Alan Turing is the work he did at Bletchley Park. He and his team may have worked in silence, but their impact was anything but. They changed the course of history. They brought an end to the deadliest war in human history. They gave us the tools we need to communicate, to compute, to connect with each other like never before. And it all started with a machine that looked like a typewriter. But can you imagine a world without computers or the internet? Without Turing, that might have been our reality. And that's why we're so excited to have you here. We set out to make history fun and engaging for everyone. And we can't do that without your support. So if you enjoy our animated history videos, please hit subscribe and join us in rewriting history together. We can make history come alive for everyone. So thank you for watching, and we'll see you next time.